Everyone, welcome back to my channel, the new video, and in this video we're continuing the advanced trees questions. This is another important question. It is hard, and well, it is hard, quite double quotes, because it's not very that hard, and it's vertical order traversal of binary tree, 7,000 thumbs up, so and asked in lots of companies. So let's answer this question, and let me see which company it was asked in. Usually you can write maybe Google interview, right? So it was asked in it was asked in Google. It's very easy, and if you don't know already, we're doing the complete data structure algorithms bootcamp, so make sure you check out the links in the description below. All the code sample and everything can be found in the description below, and the tree playlist also. If you don't know about trees, we have done like an entire tree playlist, which is what we are continuing in this video. So yeah. Okay, so the question is vertical order traversal. Vertical order, very easy. This is a tree. You have to print it in vertical order. So output should be 9 should be first, 3 should be after that, 315, then 20, then 7. So if I talk about this tree, we have 3 over here. Oh, sorry, you can't see. So it says 3, 9, 20, 15, 7. 3, 9, 20, 15, 7. Okay, so the question is vertical order traversal, meaning you can imagine, you know how we imagine levels like this? We imagine levels. Instead, we are going to imagine columns. 1 column, 2 column, 3 column, 4 column. Please remember that I'm not even doing the question right now. I'm just explaining what it is. 1 column, 2 column, 3 column, 4 column. So the output should be something like, this is vertical order, right? So the output should be equal to column number 0, 1, 2, 3, for example. This 9 should be printed first. After that, 3, 15. After that, 20. After that, 7. That's the question. So what do we do? How do we do this question? I would say pause this video and try it yourself. Give it 20 minutes. If you can't do it after 20 minutes, watch the video. But before I allow you to do that, what is like a bad way to do it? What's like a very naive brute force approach to do this? We can take the root node. If I talk about the question over here, this here says 0, 0, meaning this is the 0th column. So the root is being taken as the 0th column. Okay, this is the 0th column, and on the right hand side of the root node, just add by 1. So next column will be column number 1, column number 2. Before will be column number -1, because 0, -1. And these are the rows: 0th row, first row, second row. That's why here it's saying this is 0, 0. Yeah, that's 0, 0. 3 is 0, 0. Yes. 20 is 1, 1. 1, 1. Yes. Then 2, 0 is 15. 2, 0 is 15. Yeah, that is correct. See, 2, 0. Okay. So this is what we know. So ideally what you can do is, for every node, calculate the distance from the 0 column. So meaning the root node. Okay. All right. So for 9, I will calculate the distance. For 15, I will calculate. For 20, I will calculate. For 7, I will calculate the distance. Right. So try to calculate that. Let's say for 9, I will calculate the minimum and the maximum distance from the root node. Same for 20, 15, every other node. This would be O of n squared, because then I would have to do it again. Like for that range minimum to maximum, I will try for all the nodes. You get the idea. It's very complicated. But we don't want to do that. We don't want to do brute force. We want to do it simple. Kunal, you're making things complicated. Don't do that. How we can solve this question very simply? Level, this is like vertical order traversal. Okay, pause this video, try it. And then afterwards, we'll look into the solution. Okay, so let's think about this. Try to think the thought process, the intuition. I need the columns. I need to know which column every node lies in. That I need to know. Okay. I also know that the root node is in the 0th column. So everywhere I go left hand side of the root node, I will go -1, -1. Right hand side I go +1, +1. Not a problem. These are the two things that I know. So I want to traverse it level by level so that I can do this thing, -1, +1. What do we use for that? You know this, breadth first search. So we will use breadth first search, and let's say we try to do breadth first search. So if we do breadth first search, here on the screen you can see, if I just zoom in, sorry, I have too many screens. I have to change, zoom out a little bit, maybe change it here. Okay, now let's say I have in the queue, breadth first search, right? In the breadth first search, we use a queue, and we add the root node first. So I will add in my root node first in the queue. So here in the queue, I will have 3. Actually, here in the root node, we have 3. Let me just, yeah. So we have 3 in the queue. I've added queue. Initially, it has only 3 in it. And this is my queue. But along with 3, I'm also going to store the column that node is in. And we know I will remove it. Okay, I will remove it. And once I have removed it, let me zoom out a little bit. I can push it. So one way is that I am able to track, because when I remove 3, I will add its children. So when I add the children, I will add 9, and I will add this -1. So 0, -1, -1. And the right child that I will add will be the the column number +1. So when I add 20, it will be the 0 +1, 1. There we go. So this is very simple. I am able to track which column the node belongs in. I am able to track that. But the problem is, how am I going to display it? If I remove this and I just display 3, that's false. I did not have to display 3. I wanted to display 9 first. So what I can do is, maybe I can store, this is very easy now. The difficult double quote part was figuring out so for example, if I remove 9, then I will add in the left and right, there is nothing. I remove, let's say 20, and I will add in 15. So this will be 15 and comma -1, 0, and 7, 2. So yeah, 0 column we have 15, that is correct. 2 column we have 7, that is also correct. So what I can do is I can store it in a hash map as I remove elements. Can I not do that? I can just store it in a hash map. So in the hash map, the key will be column nodes, maybe in a list or something. So I removed 3, column 0, I will add 3 in it. Then I remove 9, column -1, I will add 9 in it. Then I will add 1, column 1, 20 in it. Then I will add 0 is already there, so I remove this, 15, 2, 7. That's it. But now what I need to do is I need to sort these keys. You can either use a tree map, but what I would recommend is just maintain the leftmost column and the rightmost column number. So minimum and maximum. So at every step when you add in an element, just try to maintain the minimum and maximum. So minimum in the end would be maintained as in a simple variable -1. Maximum column is 2. Run a for loop from -1 or from min to max. So when I run the for loop, it will be like start from -1, -1, print all the elements, 9, 0, print all the elements, 3 and 15, 1, print all the elements, 20, 2, print all the elements, 7. Oh, done. Question solved. Answer. Easy. Okay. Sounds good. What is the time complexity for BFS? O of n, right? Space complexity. What is space complexity? What all extra spaces we are using? We are using a hash map. We are using a queue, right? So how do we solve this? Okay, so O of n for the hash map, O of n for the output, because that's my output. And for the queue, also O of n. Okay. Why Q is O of n? Because we have already covered this in breadth first search. Watch the tree playlist, BFS, DFS. There I have covered why the space complexity of BFS is O of n. But it's very simple, you know. Think about what is the maximum number of nodes that can be existing in one time, right? And then whole tree concepts like maximum number of nodes at a level, at a leaf node or whatever, right? So you know maximum a level can contain is n plus 1 by 2. Okay, so that's the worst case scenario, O of n. So space complexity is also O of n, O of n plus O of n plus O of n, O of n. Very simple. I think it's very straightforward. It's just it has a lot of moving parts. That's why it is in the difficult category, but it is not a hard question. It's an easy question. Let's code it. Okay, so this looks easy. Let me see how we can do this. This is what we are given. Okay, vertical traversal. New file. Vertical traversal .java. Okay, this is what I need to return. So I need to create a list of list. Array list. List of, just copy this, integer. Okay. Return the answer in the end. All right. I'm going to call this node. If node is equal to null, just return the empty answer. What do I need to do after that? I need a hash map. I need a queue. Okay. I need a queue, hash map, and I also need to maintain the column. So let's say initially column is equal to 0. I will say queue map.entry because I need to store it, store the entries of the map, and it will have a tree node of this Yeah, that's the tree node will be 1. What will be the other one? Integer. That's my queue. Okay. New. Let's say we take a deck. Okay. Sounds good. Okay, after this I will have a map of, I will have integer. I will have integer, and let's say this is the, I will take an array list. Array list of type integer. Hash map. Okay. Sounds good. I will add in the first element, new. First of all, I will take, okay. So here we are adding a new map entry. So I will take an abstract map entry, abstract map dot simple entry of node and column. Okay. Minimum 0, maximum also initially 0. Now, while my queue is not empty, while my queue is not empty, what am I going to do? I'm going to pop from it. Entry type. So map dot entry of type, is it of type, what is the type of the map entry inside the queue? Here you go, just copy this. Removed is equal to queue dot poll. It will remove the one with the most. Once you have removed it, I will get the value. So node will be equal to the value, and the key, and the column will be the value. See, the column is the value. So this is also a mini map that I have taken. Okay, so this 309 minus 1, where the key is the value, and here the key is the node, and the column is the column that it is in. The value is the column that it is in. Sorry, I've been working too much, so my mouth is running slower than my brain. But I hope you understand. It's very simple. See now, this thing, I am storing in a queue some entity. So if I 3 comma 0 9 comma minus 1, what is this 3? It's just the node of the tree. What is this 0? The column it belongs in. So this small entity I have taken as a map entry. Okay, where the key is equal to the node and the value is equal to the column. So node will be equal to what? Remove dot get key, and column will be equal to what? Get value. Hope it makes sense. If this is not null, what am I going to do? Check if map dot contains this column. If it doesn't contain, then create it. Map dot put, I'm going to say column, and I will create a new array list because this is an array list over here. So create a new array list. Okay. Of type integer. Right. Okay. So what am I going to do after this? I will just say map dot get the column, and inside this add node dot value. That is it. Okay. And I also have to update my min and max. Okay. And then I will add 2 children in the queue because this is very simple. That's what we do. I will create a new abstract map simple entry. Simple entry of type what? Now I don't have to add the type. Node comma, not node. Node dot left and node dot right. So column will here will be +1, here will be -1. Okay. After this thing is done, I am doing this thing. For min to max, I will add it in my answer. Okay. Answer dot add map dot get. That's it. Simple. All right. Okay, so that was an easy question. Well, term that's hard and asked in Google, very simple. We discussed the time complexity, running of it, and everything else. And the code can be found in the description below. We'll do more such questions in the coming few videos. And if you have any doubts, questions, let me know in the comment section below. And make sure you like, share, and subscribe. Check out the description. All the stuff is mentioned over there. And previous videos, all sorts of things, assignments, code. And I'll see you in the next one. Have a great day.